Okay, we're going to have an assessment coming up on Thursday. So let's go ahead and review some of the things that we have learned that we're definitely going to be seeing going forward. Let's go ahead and multiply some fractional amounts. 5 times 2/3, what would that be? It's going to be 10/3. Anytime you see an improper fraction, you immediately are going to be converting it to a mixed number, right? So you can make 3/63 and 1/3, converting to a mixed number. No problem, do it all day, all night, right? Well, let's think about what if we see this type of problem on a number line. And all right, and you see that amount. So how much would you have if you had that amount? It's sort of like a certain amount of jumps down the number line. Well, this one's going to be pretty straightforward, but still the number one thing that you want to do, and this was like day one of fractions, I want to know what denominator I'm working with. So in order to know, I see that there's 1, 2, 3, 4, 5, 6 jumps, but what are each of those? That's my first priority. So how would I name just one of the parts? Well, there's only one way. I know that's one, but I don't know one what. From here to here is one what. Only one way to find out. How many of this amount does it take to make the whole? Well, I've got to find where a whole is. It's not the whole number line, it's one whole. And I can see that right there is my one whole. And there's 4 parts in the whole. Therefore, I know that I would label from there to there 1/4. Knowing I'm working with fourths is everything, because now I can easily interpret what this would mean. 1, 2, 3, 4, 5, 6 fourths. So right there is 6 fourths. And immediately I'm going to be converting that to a mixed number. I can make one whole and I'd have 2 fourths left. To make it the most simple, I see that both of these numbers can be divided by 2. So I'll probably divide 2 and end up with 1 1/2, the simplest, most straightforward, clear way of describing that amount. Okay, let's investigate some more number lines. Okay, this amount. How much does this amount represent? Well, I see there's 1, 2, 3, 4, 5 jumps, but 5 what? Again, first priority, whenever you see a number line that's not completely labeled, you go hunting for one whole. Now from here to here is one whole, but if I hadn't seen, what if the number line started there? I'd have to go searching for another whole, and I see that from here to here is a whole. So I could have gotten my information from that one just as easily. So you're not always just looking how to get to one, but I just want one whole. That's a whole, that's a whole. And if this went on, I'd continue seeing wholes. I've just got to find a whole so that I can determine what denominator I'm working with. There's one whole here. There are 1, 2, 3, 4, 5, 6, 7, 8 parts. Therefore, I know we're working with 8s. So that'd be 1/8, 2/8, 3/8, 4/8, 5/8. The most important thing, number line, find one of the wholes, right? Even if it's not at the beginning. That's how you're going to determine your denominator. And from that point, you can figure anything out, right? How about this one? I see that there's some amount and it goes, this is where it stops. That's the amount it stops at. I know I see 1, 2, 3, 4, 5, 6 jumps. I don't know what these are yet. So I'm going to go searching for anywhere on this whole number line where I can determine one whole and be real clear about it. And I see clearly that there's one whole represented here. How many parts are in the whole? 1, 2, 3, 4, 5. Therefore, all of these jumps are fifths. Now, how many fifths would it take to get to this distance? Now, remember, just because we're focusing in on one little part of the number line, we can't ever forget that it continues on in both directions. So the amount started at 1, started at nothing, and it got all the way to here. How many fifths would it take to get to this point? Which is basically 3 and 1, 2, 3 and 3 fifths. How many total fifths would that be? Reason through it. Well, the first from 0 to 1 would be 5/5. From 1 to 2 would be 5/5. From 2 to 3 would be 5/5. I'm already up to 15 fifths. And then 1, 2, 3 more, plus 3 more fifths. This place right here represents 18 fifths, or 3 3/5. Number line. Go looking when you're working with fractional amounts. Find out wherever there's one full whole, you'll then have your denominator. At that point, you can reason through any question that you'll be asked. So remember that when you're working with number lines.